Hello everyone, today I would like to go over a question on approximation by trapezium rule and the Simpson's rule. So the question asks us for finding those approximations for the integral e to the x over 0 to 1. So for the trapezium rule, for the 6 intervals, the formula can be expressed as the width of each interval h over 2 times inside the bracket function evaluation on the left hand side, which fx0 plus 2 to the second function evaluation fx1 plus dot 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 and 2 times f over x5 plus x6. And our width is 1 over 6 times a half. Our function evaluation happens at 0, 1 over 6, 2 over 6, and 2, 1, which can be evaluated as e to the 0 plus 2 times e to the 1 over 6, and 2 times e to the 5 over 6 plus e to the 1. So if we put all this into a calculator, we get the final solution to be 1.722257 to 6 decimal places. I'll write this into our answer box up there. And then we move on to the Simpson's rule, which is using curvature to approximate every 2 bins. The Simpson's formula, S of 6, equals the bin width h divided by 3 times f of x0 plus 4 times f of x1 plus 2 times f of x2, alternatively 4 times 4 times 2 until 4 times x to f of x5 plus f of x6. And the width is still 1 over 6, and then times 1/3, and f of x0 is e to the 0, f of x1 is e to the 1 over 6, and then we just evaluate the function f by e to the x. And if we put the last line into our calculator, we would get 1.718289 to 6 decimal places. And then it asks us to find the error of each of our approximation. So we need to find a true integral solution for this. Integral of e to the x is still e to the x, so the integral is e to the 1 minus e to the 0, which is 1. So it's 1.718282. So the error of e to the t is calculated by finding the difference in absolute term between our approximation and the true solution. And in this case, the error is 0.003968. And we can do the same for our Simpson's rule by finding the difference. In this case, the error is much smaller, is 0.507. So as we can see, the Simpson's rule is much more accurate in this case. For second part of the question, it asks us to find the error bound as given by the textbook. The error bound of the trapezium rule can be expressed as the width of integral to the power 3 divided by 12 times n to the power 2 times the maximum over the interval and of the second derivative of function f. Our integration width is 1, so b minus a is 1, and number of bins is 6, and the second derivative of e to the x is still e to the x, so we want to find the maximum of e to the x over 0 and 1. So e to the x is an increasing function, so the maximum value happens at e to the 1. If we put that in, we would get our error bound to be less than or equal to 0.006292. Write this into our solution box. And also there is a formula for finding the error bound of the Simpson's rule, which is less than or equal to b minus a to the power of 5 over 180 into the 4. And in this case, it's still the maximum over the interval for x, but it's a fourth derivative of that. And the fourth derivative is still e to the x, and so the maximum happens in e to the 1. And we can solve this error bound to be 0.4012. And we can put this into our solution box. It's nice to compare though, our error bound is bigger than our actual error as in there. So that's all for this week. Thank you for watching.